Okay, good morning, everyone. I hope you can hear me. Okay, for today's lesson, it's 1.5 hours. Okay, the objective of this lesson is to cover as much as we can for our next chapter. So now I will need you to make sure you have your class kit ready. Okay, we are going to start with the class kit set number 24. Okay, I'll be sharing screen very soon. So make sure you get ready your class kit, then we will start. Okay, I hope you have found the notes, set number 24. The title of the notes is called Compounds. Okay, what are compounds? We have actually covered this in the previous lesson, but I'm not too sure how many of you still can remember. So let me just run through it again. Okay, you will need to copy down the blanks if you have not done so. Okay, first of all, I hope you can see the screen, the shared screen. You may need to pause the video. That means as you watch the video, you realize there's blanks to copy. Pause this video, then switch over to your class kit, fill in the blanks. Then after that, resume with the video. Can? Okay, first of all, this is the definition for compound. What is definition? Definition means something you must memorize. Must, I use the word must. You must memorize. Okay? So what is a compound? Usually exam, they like to ask this question. A compound is a substance that is made out of two or more different elements. I give you an example. Example, carbon dioxide. There are two different elements and they are chemically combined. How do I know it's chemically combined? Because the carbon and the oxygen, they share electrons in the covalent bond. Remember your covalent bonding? Yeah, they share the electrons. You know, I draw for you. If you have forgotten, this is the sharing. Remember the dot and cross, dot and cross. Yeah, this is what I mean by the sharing. So they have bonded chemically. Understand? This is chemically combined. So two or more different elements. It must be different. So I have different elements, carbon and oxygen. So when they chemically combine, I call this a compound. Okay, let's move on to point number 2. Point number 2 give you some other examples of a compound other than CO2. I have things like H2O, water, which you should know is also two different elements chemically combined. I can have 3 different elements chemically combined. That's my calcium. Okay, I hope you can recognize what are the 3 different elements chemically combined for calcium carbonate. Okay, calcium carbonate is made out of calcium. That's one. Carbon, that's the second one. And oxygen, that's the third one. So 3 different elements chemically combined. It is a compound. So all these are some examples of the common compounds. There are many compounds. As you have learned in ionic bonding, any metal combined with any non-metal is an ionic bonding. And that is a compound because it's chemically combined through an ionic bond. So there are simply so many metals and so many non-metals. You get many different compounds. Okay, here is just the common ones. Okay, things like ammonia, must know the formula is NH3, that's for ammonia. Sulfur dioxide, carbon dioxide is CO2 and SO2. Methane, methane is a gas. Okay, it's a gas. It's quite a smelly gas. Methane, CH4. Water, sodium chloride, NaCl, and calcium carbonate. Okay, let's move on to point number 3. elements can combine in a chemical reaction to form a compound. Okay, this is a compound. You need a chemical reaction to chemically combine it. So if you don't have a chemical reaction, then you don't get a compound. Okay, so what is a chemical reaction? Example, things like you need to heat it up. You need a lot of energy to react. Like carbon and oxygen, you put a piece of carbon in the air, the carbon will turn to carbon dioxide one. But you take the carbon and you burn it. Carbon you burn until very high temperature with oxygen. Then of course the carbon will turn into carbon dioxide. Okay? So you need a lot of heat for this chemical reaction to happen. And of course, it's irreversible. I mean, you burn the carbon already, the carbon becomes carbon dioxide. How to get back the carbon? You cannot get back carbon, right? So it's irreversible. Okay, so when you go through a chemical reaction, the things change. Change what? Change the properties. Physical properties also change. Chemical properties also change. They are different now. I give you an example. Carbon is black color. You burn, become carbon dioxide. Carbon dioxide is not black. Carbon dioxide is colorless gas. Okay, so the color change. The chemical properties also change. Okay, carbon dioxide is a gas. It's a gas, it's an acidic gas. Okay, that's why they bubble the carbon dioxide into your Coca-Cola to be acidic. Carbon is not a gas, it's not acidic. So the chemical properties also different. Okay, so remember the point here is when I form a compound, I need to go through chemical reaction. When I go through chemical reaction, everything change, properties change, all become very different. And it's irreversible. Okay, let's move on to point number 5. This one, I think we can talk about it roughly and very briefly. When you write a compound, the metal must come first. So you call it sodium chloride. We don't call it chloride sodium. So it's the metal. Sodium is a metal. Okay. Metal will come first, followed by the non-metal. Can. So remember, when you name a compound, if it involves both a metal and a non-metal, you have to put the metal first. Okay. Next, when I have a compound with only 2 elements, the name often ends with IDE at the back. Like sodium chloride, I have IDE. IDE stands for the chloride, oxide, dioxide, carbon dioxide, example. Or bromide, I have IDE at the back. Okay. The next thing is sometimes we have this thing called OH. What is OH? OH is called hydroxide. Hydroxide is OH. So sometimes I combine with a hydroxide, I get sodium hydroxide. So I get NaOH. So every time you see a hydroxide in the name, it means there's an OH. Any question? So far, so good? Can now? Okay, let's move on. So sometimes, other than the IDE, you have an ATE at the back, like carbonate, nitrate, sulfate, or the AT at the back. What does that mean? It means to say it contains oxygen. There's oxygen in the compound. Okay, I have oxygen reacted. Oxygen is one of the elements chemically combined to form the compound. For example, calcium carbonate, I have oxygen, CaCO3. Silver nitrate, I also have oxygen, NgNO3. Lead sulfate, also oxygen inside, PbSO4. So you see the word ATE simply means it contains oxygen. Okay, next, regarding the formula, when I write a formula, there's a small little number at the bottom. Okay, example, the easiest to talk about is H2O. The 2 is a very small little 2. This 2 is written on the right hand side of the H. Okay, I repeat. So if you don't know what I'm talking, this 2 is written on the right hand side of the H. What does it imply? It implies that there are 2 hydrogen. Okay, 2 hydrogen that combines with 1 oxygen. Can? So if I never write any number, it means 1. In this case, the O for H2O, the O has no numbers. No numbers means just 1. But if I need more than 1, let's say 2, then I'll write 2 on the right side of it. So H2O means 2 hydrogen. CO2 means 2 oxygen. The number is to the right hand side of the element. Any question? If there's only 1, like CO2, only 1 carbon, you don't need to write the 1. It understood the CO2, 1 carbon, 2 oxygen. Can? So far, so good. Okay. Okay, there's a Roman numeral. Roman numeral stands for the oxidation state. You can skip this one first. We'll not cover oxidation state. Oxidation state is like set 5. Okay, but just to let you know, sometimes you see these weird things in brackets. The number inside the bracket refers to oxidation state. What is oxidation state? When you come back set 5, then I tell you. Okay, next one. For covalent molecules, usually we name the entire compound by counting the number of atoms. So if you see a word di, mono, okay, like I give you one more, sulfur trioxide. Tri, you see the word tri, means 3. Okay, so I repeat, sometimes you see the name di, tri, di means 2, like diameter. Tri means 3, like triangle or tricycle. Mono means 1. Okay, can just take note of the di, tri, mono. Okay, then for others we use their common names. Yeah, sometimes we have common names like water. It's called H2O lah. We don't call it dihydrogen oxide. A bit lame. Okay, dihydrogen oxide is like H2O lah. I got 2 hydrogen, 1 oxygen. Actually it's called dihydrogen oxide. Sorry, ends with IDE. But we don't call it dihydrogen oxide. Just call it water H2O. Okay? Can? Yeah. Okay, let's move on. Name the elements present in the calcium carbonate. But you have not answered this question. That means you must be daydreaming. The elements are calcium, carbon, oxygen. How do I know? Check the periodic table. Where to find the periodic table? Google. Where? I have calcium, carbon, oxygen. Is ammonia a compound? Explain answer. I'll give you 3 lines to write. Okay? You cannot just write one word answer. Answer is yes. But I want you to explain. How to explain? Remember the definition that I told you must memorize? So you use the definition of a compound to tell me why this is a compound. Okay, that will make a lot of sense. If not, you need a definition for what? So you tell me the definition. Okay, yes, it is a compound because, okay, ammonia is made out of 2 or more different Sorry, there's no two or more. There's only two. Okay, two different elements. If you can tell me the two elements are nitrogen and oxygen and hydrogen, that will be very good. It's made of two different elements chemically combined. I must see the word chemically combined. It's a keyword. Understand? If not, the nitrogen in the air just float around, the hydrogen in the air also float around. These two things float around, how to give you ammonia? It will never give you ammonia. The nitrogen will just float around in the air, the hydrogen will just float around in the air. You need a chemical reaction to combine them. Remember the chemical reaction? I need some heat. So I must have the chemical reaction to chemically combine. I must see the word chemically combined. Okay? Okay, so the chemical of the methane, CH4. How do I know? It's not that I pop it out from the air. You go and remember the common ones, like water is H2O, everyone knows. Okay, carbon dioxide is CO2, this one everyone knows. You try to memorize a bit more like methane. Methane is CH4. Ammonia is NH3. Won't kill you. I mean, just a few more won't die. Okay? So, yeah. I say CH4. Okay, let's move on. Okay, first of all, let's look at what exactly is inside a compound. Okay, so for a compound, it can be made out of molecules or ions. So for example, I have this molecule. I have a water molecule. Okay. So H2O, I don't know how much you know about H2O. If you draw the dot and cross diagram, it's a covalent molecule, covalent bonding. 1, 2, 3, 4, 5, 6. Yes, oxygen got 6 valence electron. So this is water, H2O. It's a simple molecule. It comprises of 2 hydrogen atoms and 1 oxygen atom chemically combined. Guys, the keyword is very important. Okay? If not, the hydrogen and oxygen just float in the air, it will never give you water. You need to chemically combine them. So that is how you form a compound, a molecule of water. Or the compound can consist of ions. Example, positive charge ion, negative charge ion. You still remember my ionic bonding? My ionic bonding. Remember the what bracket, then plus, then what bracket, then minus. Ionic. So I have the metal and the non-metal. Remember? So example, sodium chloride. Sodium is metal. So it's Na plus and Cl minus. Na plus, all these are the Na lah. Then my Cl minus. This one all the Cl. So this is ionic bonding. So it can also form a compound when a metal and a non-metal compound combine chemically again. Then I will get an ionic compound. Any question? Can? So in other words, I summarize for you. Compound can be formed covalent through covalent bonding. It can form also through ionic bonding. Okay? I hope you know what's the difference between ionic and covalent bonding. This one we have talked about it like don't know when. Okay? Can? I hope it's okay, no question. Okay, if not, can you take a look at the next few questions for a while? Okay. Now let's look at the question. Chemical formula. State the number of carbon and oxygen atoms in carbon dioxide. Okay, so for carbon dioxide, there are two elements, carbon and oxygen. They already tell you. You look at the formula, the answer is 1 carbon atom and 2 oxygen atoms. Okay? Can? Any question? The next one also can do. Iron and oxygen. Iron is Fe. Okay? Iron is Fe. So I have 2 iron atoms and 3 oxygen atoms. Quite easy, right? State the number of iron, nitrogen, and oxygen atoms. Wow, this one how to do. Okay, first of all, I got 3 different elements. I got iron, I got nitrogen, I got oxygen. Okay, so there are 3 things over here. Okay, this one is a bit harder because there's a bracket. And where is the bracket? You look carefully, the bracket is surrounding the NO3. And after that, there's a 3 outside on the right of the bracket. So I can safely say my iron, there's only 1 because the iron is not affected by the bracket. There's just 1 Fe only. Now let's look at the things inside the bracket. Okay, I have the nitrogen. So my nitrogen is inside the bracket, and this bracket is times 3. So 1 nitrogen inside the bracket times 3 means I got 3. I got 3 nitrogen atoms. Next, I look at oxygen. Oxygen, on the other hand, I have 3 inside the bracket. Then after that, I need to multiply outside with 3. So 3 inside multiply with another 3, total is 9. So I will have 9 oxygen atoms. Can you get the answer? Can I? I hope no issue. Okay. Okay, let's look at the past the year exam question. This was like last year's end of year. They give you a very complicated compound. Okay, I don't know what's the name called. It's what KO99. So they give you a formula. What is the total number of elements and atoms present in 1 molecule of KO99? Okay, I don't know whether you can click and get the correct answer. So far, let's take a look. This is aluminium. Okay, aluminium. I have silicon. That's the second one. Si is silicon. I have oxygen. That's the third one. And oxygen again, so I don't count. I have hydrogen. That's the fourth one. So in total, I have 4 elements. Can any difficulty with that? Okay, if no, then the next question is how many atoms in total? You need to add them up, Add. So how to do? Let's take a look at the number. This is aluminium. The number is 4. I have 4 aluminium. This is silicon. The number is also 4. This is oxygen. The number is 10. Correct? Okay, now we have the bracket. You look at the bracket, there's an O and a H inside. 1 O and 1 H in the bracket. Then the bracket is going to be multiplied by 8. So what does that mean? That means we have another 8 oxygen. Okay, and I have also 8 hydrogen. Because 1 hydrogen times 8 outside becomes 8 hydrogen. Then you add them all up. Okay, 4 plus 4 plus 18. 10 plus 8 is 18. 4 plus 4 plus 18 plus 8 is 34. Can. So the answer is A. Sounds complicated, but if you slowly take your time, you should be able to solve. Which chemical formula contains the greatest number of oxygen atoms? Wow. Okay. Let's do some math. Okay, I'm just interested in oxygen only. I don't need to go through all the hassle of finding every single element. Don't need. So I only focus on oxygen. So let me highlight the oxygen for you. This is the oxygen. Okay, oxygen. Oxygen. Yes, only the oxygen I'm interested. Can. No issue. Okay, so here I have 4 oxygen, but it's multiplied by 3 because the oxygen is inside the bracket. And I have 4 oxygen inside the bracket. So I need to multiply it with the number outside the bracket. So 4 times 3 is 12. This one, 7. Okay, it's just 7. This one, 3 times 3 is 9. And this one, also 3 oxygen times 3 oxygen is 9. So the answer is A. There's 12 oxygen in total. Yes, the most number of oxygen atoms. Any question? Is it very easy for compound? I hope it's not too difficult. Okay. Okay, if not, no question. I need to jump over to the next set of notes. Okay, that's number 25. So make sure you have number 25 ready. Okay. I am number 25 now. You don't know whether have you switched to number 25. If you have not switched to number 25, you quickly pause the video and switch to number 25. Then after you switch to number 25 already, you unpause the video, then you continue. Okay. For set number 25, we are done with compound. We are going to start with this thing called mixture. Okay. I will write down the definition for compound. A compound consists of 2 or more different elements chemically combined. You don't believe me, just refer back to the previous note. Okay, this is compound. We are done with compound. Our focus now is mixture. So if you look carefully, I don't use the word elements. I use the word substances. And I also have this word called not chemically combined. Okay, I must have the word chemically combined, but include the word not. Okay, not chemically combined. That means I just mix. Okay, I give you an example. What is a mixture? Sand and water lah. Sand and water, you put them together, it's a mixture of sand and water. They never react, they never go through any chemical reaction. You still have sand and water when you put them together. So that is not chemically combined. It's a mixture. There are 2 different substances. First, one is water, one is sand. I don't call that elements because they are not elements. Sand is sand. Okay, so sand and water are 2 different substances, not chemically combined. I mix them together, I get a mixture. Okay, so some example of mixture are air. Air got what inside? What is inside air? What do you mix to get air? You mix what? You mix oxygen. There's oxygen in air, right? Obviously. You know how you breathe. There's carbon dioxide in the air. Definitely. That's how you breathe out also. What else? There is also nitrogen in the air. And many other gases. I will not talk about it now. You will learn it in Site 4. Okay, but these are the three main gases, oxygen, carbon dioxide. So it's a mixture, you see. I mix all these gas. I never react with them. Oxygen is just oxygen. It's an element is existing here now, and you breathe in. It never react away and turn to something else different. So it's still there, oxygen, just mix it together with carbon dioxide and nitrogen. So it's a mixture. Okay, other things like milk is also a mixture. Coca-Cola is also a mixture. Coca-Cola add what? I mix water with sugar. That's why it tastes a bit sweet. I also mix water, sugar, and artificial coloring. That don't know what color, black color dye. Let me mix that. Coca-Cola. So it's a mixture. Okay. So milk, Coca-Cola, all these are mixture. Alloys such as steel is also a mixture. Okay. So an example of mixture is bronze. Bronze is a mixture of two things, copper and tin. I mix them together. I can have any proportion. Okay, I can have a lot of copper and some tin. So you see they are actually a lot of copper. Okay, all these small little circle represents copper. So there are many copper surrounding a tin. So it's a mixture of two things, copper and tin. It's a mixture. Any question? So this brings us back to this. This one I tell you is must memorize. I'm not joking with you. That time I ask you memorize the FAME table, FAME. Nobody go and memorize. Memorize half. Move rapidly, never tell me randomly. Arrange orderly, never tell me is it orderly, is it very close or far? Everything half memorize. Some words, some never go and memorize one. This time round, I also another table. It's not the FAME table. It is called the SPECT, spec table. So what is this spec table for? This spec table is to compare compound and mixture. Okay, so in the exam, how I ask? I'll ask, give me two difference between the compound and mixture. Then you must tell me what the two differences are. Don't anyhow say, okay? There are a total of 5 SPECT. 5. S stands for something, P stands for something, E stands for something, C and T also stand. So there are a total of 5 differences. Okay, for compound and mixture. So what are the 5 SPECT? First, the S stands for separation. Okay, so how you separate a compound and how you separate a mixture is different. Okay, we start with the easy one, mixture. A mixture very easy to separate. If I iron filings and water, how to take out the iron filings? Use magnet. This one common sense, right? You have a sand and water, how to separate? Also common sense, right? You go and filter lah. So for mixture, it's very easily separated. Don't need to go through any drastic chemical reaction to separate them. Very easy one. All like sand and water, do what? Filter. Just take one filter paper, pour can already. So this is mixture, is easily separated by physical means. Physical means like things like physical things like filter paper, magnet, all these physical means. Okay, use physical objects. Use all these, know what thing you call these objects to separate them. But for compound, cannot. You need a chemical reaction. I give you an example. This is a compound. Why is it a compound? Because it consists of two different elements, hydrogen and oxygen, chemically combined. So water is a compound. If I want to separate, I want to take out the hydrogen and the oxygen. Wow, there's no way you have filter. You filter and filter and filter. You pour water through layers of filter. You will never get oxygen. Okay? You use a magnet, you cannot attract out the oxygen. So how to separate them? How to get oxygen separated from the hydrogen? Wow, very difficult. You need a chemical reaction. So I need to use very drastic things like electricity, or we call electrolysis. You need to pass electricity, high current, a lot of voltage to split the two of them up. Then I can split and I get hydrogen and oxygen separately. Can? So that's the first one. Out of the SPECT, the S, separation. Let's move on to the second one. The second one is called properties. Okay, if I'm talking too fast, you just pause and rewind back the video. Second one is called properties. P for properties. What do I mean by properties? I have physical and chemical properties. The properties, both physical and chemical, are different in a compound, and the other one is similar in a mixture. Let's talk about the compound first. So example, H2O. H2O is a compound. It is called water. Okay, it's called water. First of all, you must understand that water comes from hydrogen and oxygen chemically combined. And the properties change after you chemically combine them. Hydrogen is a gas. Oxygen is also a gas. In fact, hydrogen is a flammable and explosive gas. But my water is not. Okay, after you chemically combine them, you get water. Water is very different. It's not explosive. It's not a gas. Okay? So you see the properties change. They are now different in a compound. But for a mixture, they are the same. I give you an example. Salt and water. I think you know how to separate salt and water, right? I trust you know salt and water, crystallization, evaporation to dryness. So salt and water is a mixture. The properties similar. You see, I put salt and water together, I mix and mix and mix. It still tastes salty. It still tastes the same as the salt. It's still salty. The properties is the same. Okay? Yes. So the properties will change. They are usually the same. The example given here is iron and water. Yes, you put iron in water, you stir. You can still use a magnet to attract down the iron. Yeah. Which is the same. It's still magnetic. The magnetic properties is still there. It doesn't disappear. It doesn't change. So for mixture, I summarize for mixture, the properties is the same or similar. But for compound, the properties are totally different. Okay, the next one, E. E stands for energy change. This one, I got talk about it lah. To form a compound, you need a lot of energy. There's a lot of energy involved. You need a chemical reaction, go through electricity and whatever not, a lot of heating. There's a lot of heat, a lot of energy change involved when you want to form a compound. But for mixture, you don't need any energy. What energy you need? Sand and water, just pour the sand in the water, finish already. And stir, you get sand and water mixture. Now got salt and water, just put the salt inside water and stir, can already. Oh, don't need any energy, right? Don't need any reaction, right? So mixture is no chemical reaction involved. For composition, okay, so far S, P, E, and C, the C. What's composition? Composition is like the ratio. Okay, ratio. Like, what's the ratio of the boys and girls in class? I don't know, 2:1. 2 boys to 1 girl. I don't know, you can count. So it's like a fixed ratio or a fixed composition for compound. Oh, the ratio is fixed. Like H2O is H2O. There's no such thing as H3O. Don't have. Or H4O. Don't have. Okay, H2O is H2O. The ratio is always H2O. It's always 2 hydrogen and 1 oxygen. So the composition is fixed. Fixed, fixed. The word is fixed, but for mixture is variable. That means not fixed. Example, sand and water. You want to put how much sand, you put how much sand. You want to put 1 kilogram of sand, you put 1 kilogram of sand. You want to put 1 gram of sand, you put 1 gram of sand. You still get a sand and water mixture. Or your Coca-Cola, you want how sweet, you put more sugar. You want very, very, very sweet, you put more sugar inside. So the Coca-Cola is a mixture. You want to put how much sugar you want to put, you put. It is not fixed. The ratio, the composition, everything can change one variable. Understand? Okay. So now I move on to the last one. For SPECT. Back. Temperature. Okay, for compound, the melting point, boiling point is fixed. It don't change. Like ice melt at 0, water boil at 100. Not standard everyone will ask, no water boil at 100, okay? You got heard of water boil at 10 degrees Celsius, right? No, right? You got heard of water boil at 50, 60, 70, you don't have, right? So, standard, water boil at 100 is fixed. Can't change it. But if it's a mixture, then sorry, it is not fixed. Very simple, what? Like you put more sugar inside Coca-Cola, then the melting point go up. You put very little sugar, then the melting point will be lower lor. So it depends, it varies. Okay, there's no like fixed melting or boiling point. Okay? Can Okay, stay tuned. This one can you just go and write? Just copy. I'm going to write only one. You're going to write 2, okay? I'm going to write one difference between a compound and a mixture. The easiest one. Okay? The other one I'm going to copy. For a compound, okay, I write energy. E is for energy. Okay, a chemical reaction is involved / energy change. Okay, energy change. Maybe we don't use energy now. You just stick to the standard, right? Is involved or taken place. Can. Then you better talk about mixture. Whereas for a mixture, no chemical reaction is involved / taken place. Okay, that's the SPECT, the E. Then the others you're going to write. S is for separation. For compound, you need a chemical reaction to separate the elements. Whereas for mixture, you can separate through any physical means or methods. Can P properties. E I will say C is composition, T is temperature. Okay, can. I trust you can write. You need to pause the video and write in your class sheet. Okay, next. Part 2, question 2. Is ethanol a compound mixture? Explain your answer. Well, how do I know? First of all, what is ethanol? How do I know what is ethanol? If I don't even know what's ethanol, how do I know it's a compound mixture? I don't know. How do I know? So ethanol is a compound. How do I know? Is there any clue? The clue is the ratio is fixed. It's a fixed ratio, How do I know it's a fixed ratio? It's stated so clearly. C2 means got 2 carbon. H5 means got 5 hydrogen, followed by OH. It's fixed. It's not like C2, H5, OH can anyhow become C6, H100, O200. Don't have. Okay? So this is the formula. It's a fixed one. H2O is fixed. All these are chemical formula fixed one. So it is a compound because the ratio fixed. But we don't use the word ratio here. We use the word composition. It's a compound because the composition. You can tell me the composition very good. 2 carbon is chemically combined with 6 hydrogen and 1 oxygen. Do you know why I got 6? I got check for free. 6 hydrogen and 1 oxygen atom. The composition is fixed. Yeah, keywords. You might tell me it's fixed composition. Okay? That's the keyword. And it's called composition. Don't worry, right? Ratio can. Ratio is like math. This one is chemistry. Name 2 examples of a mixture. Okay, 2 examples of mixture. Should not be too hard. The first one is called air. You say air is a mixture. What's the second one? Oh, so many. Other than air is what are some example of a mixture that you know of? Huh? So many example, muddy water lor, milk Coca-Cola. They are actually more mixture in around us. Medicine also mixture. So many things. Orange, the artificial orange juice is a mixture. Everything. Okay? Can your add so all these artificial sweetener, everything add together, mix. So all these are mixed. Oh, just give me 2 examples, can already. Okay. Let's look at the past 30 exam question. Again, this is like last year's end of year. Which list contains an element, mixture, and a compound? Okay. How to solve? The easiest one is element. Let's see which one is element. How do you know which one? Check the periodic table. You can find that in the periodic table. Example is this. This is an element, copper. Copper is Cu. Go and check. It's fine. You can find Cu in the periodic table. Gold is an element. Gold is Au. You can find it also in the element. How about the periodic table? Iron, just now I said it. Iron, Fe. You can find that also in the element, in the periodic table. Okay. Nitrogen is N, of course. You can find that in the periodic table. So it's an element. You cannot find air in the periodic table, definitely. So these 4 things are elements. Okay, let's move on. What do we have next? Mixture. Okay, air is a mixture. This one is standard. I just tell you already. Air is a mixture. What else is a mixture? Fuel is a mixture. Yes. How do I know? It's in the notes. Where is it? Can find? It's here. Here. Point number 2. Okay. This is a mixture. Mixture of iron plus carbon. For your info. Anyway, you'll learn it in Sec 4. Okay, steel is a mixture. So yes, I have a mixture. Any more mixture? This one air say already. Salt water. Yeah, salt water is a mixture because it adds salt and water mixed together. So it's a mixture obviously. Salt and water means you add salt. You want to add 1 kg of salt also can. Okay, salt and water is a mixture. Okay, next. Compound. Where's my other part? Compound. So which one is a compound? are the remaining ones lor. Carbon dioxide, of course. I already say what CO2 is the ratio is fixed one. It's chemically combined. The carbon and oxygen react. Copper 2 chloride. Yes, it's a compound because the name weird one ends with IDE, ends with IDE. So all these end with IDE, copper 2 chloride, CuCl2. It is a compound. Water obviously is a compound. H2O, the ratio is fixed, 2 hydrogen and 1. Okay, so you look at the answer lah. The answer is C. Okay. I must have one element, one mixture, and one compound. Can any problem? I hope no. So so good. Okay. Okay. Let's move on. Wow, this is difficult. 5 marks. It looks so easy just to put 5 ticks. Every tick that you put costs you 1 mark. The question is, do you know which one is element, which one is compound, which one is mixture? Okay, let's look at the first one. The first one, I want V. Okay, let's look at V. You look at the story here. Do you know is it an element, compound, mixture, or better still, it can be an element or it can be a compound. You don't know. If you think it belongs to that category, then you put a tick there. Okay, so let's begin. V is a green solid. Okay, I tell you, green tells me what? Green tells me it's not a metal. It's definitely not a metal. What's metal where got green color one? Tell me. I got see metal that's green color before. Metal is definitely silver color or gray color one. Then gold metal gold is gold color. Where got green color? So definitely V is not a metal. Okay, first of all, it's not a metal. Next, that can be separated into a white solid and a green liquid after adding water and filtering. That means I can filter and separate them. Means what? Means this is confirm a mixture lor. No, you filter, you pour the solid up at the top, the liquid go down. Also, mixture lah. You mix the solid and liquid lah. So now you can filter it lah. Separate them. So V is a mixture. Okay, remember just now the SPCT, what was it? As separation. Mixture can be separated using physical methods such as filtration. Or compound cannot, compound uses electricity. Okay, next one. Next one, I want W. Okay, a colorless substance W with a fixed melting point and a boiling point. Okay. When I say fixed melting and boiling point, definitely it's not a compound. Because a compound don't have fixed melting. Sorry, definitely not a mixture. Because a mixture has a variable melting and boiling point. Definitely not a mixture. Don't go and choose a mixture. So when I have fixed melting and boiling point, it can be a compound. Or it can be a element. Really? I give you a colorless element. Example, oxygen lah. Oxygen is colorless. Okay? It has a fixed melting and boiling point. Alright. I give you another compound, not element. Water. Water is also colorless. It has a fixed melting and boiling point. Correct? Boil 100 degrees Celsius. So it can be either an element or a compound. I won't know. Then unless tell me can be separated using electricity or what. Okay? So no, they never say much. They just tell me colorless. Okay, X. A solid X which melts into a silvery liquid that cannot be broken down into. This is the definition for element. I don't have my notes for element now. If you have, you can take a look. It's the definition of element. What is an element? Element is a substance that cannot be broken down into 2 or more simpler substances by chemical means. So it cannot be broken down further already. It's the simplest already. Okay, so it's element X is an element Okay, Y. Y is sounds like a reaction. I got Y, go and heat it, then got Y, like explosion, got light come out, got what. So when you want to make this substance Y, oh, you need to go through a lot of heat, a lot of things, got light and heat produced. This one's compound confirm. Or your mixture, where got heat and light one, you pour the same in the water, just pour in. So only compound, then you need a lot of heat and light and what. Okay, next one, chromatogram. This one confirm mixture. This is like separation technique, physical separation, filtration, crystallization, chromatography, still what? Fractional distillation. All these are physical method, you separate them. Okay, so my black liquid is a mixture of different color liquid. I'm black lah. So it's a mixture of different color liquid. That's mixture. You mix different color liquid together. Okay? Am I done? 5 ticks, 5 marks. Hopefully you understood the things inside. So far so good. Okay, no question. Let's move on. Okay. What is this? Please move this window away from the shared application. How to move it away? I also don't know. Never mind. It's okay. I hope it's not blocking something. No, I hope not. Okay. This question. Question 3. Let me minimize this. My screen sharing is paused. Why is it paused there? New share. Okay, let me share again. Okay. Now I share again. Hopefully you can see the screen. Okay, this is question 3. Yes, question 3. Yeah, why is this thing still here? Okay, hopefully it's better now. Okay, for question 3, they ask you to write down whether is it an element, compound, or mixture. Okay, so first question, is it must be one each, or is it can be all compound or all mixture? So how do I know? First, the easiest, or it's always easiest to find the element. You can find in the periodic table means element. So the answer is sodium. Sodium is the element. You can find sodium. Where you find sodium is in group 1. Yeah, you can find for it there. Okay, next one. What is salt solution? Do you know what salt solution? I hope you know what salt solution. Salt solution is when you add salt to water. Or in other words, you try to dissolve the salt in water. This is a mixture because I can anyhow add how many salt I want. The water lah. Okay, you want more salty, then add more salt. So it's a mixture. I can mix any proportion. I can also easily separate it. Just evaporate, get the salt. Okay. This is the salt, like NaCl, the salt that you eat at home. Okay, this is a compound. Why? Because how to separate? You take out the sodium for me. Sodium is a metal. How you take out the metal? This is the salt you eat at home. You know the white color salt they eat at home? Yeah, inside got metal. I mean, it's made out of a metallic element, sodium, chemically combined to chlorine. So there's no way you can take the sodium metal out from the salt, right? Unless you use electricity. Then we different story lah. But over here, anyway, electricity means compound already. You need a lot of electricity energy. Okay, so just nice. I mean, one each element mixture compound. Okay, see one difference. You're not going to write yourself. Is a SPECT. Just choose one. You see, every year standard, they like to ask people. So go and memorize the SPECT table. Don't take chance. Don't say, hey, I only memorize one can already. No, go and remember all 5. Understand? Any questions? So far so good. Can right. Not too difficult, I hope. Okay, if no question, what are we going to do? We are going to move on to the next one. Number 26. Yeah, number 26. So can you go and find in your class kit number 26? Okay, go and pause the video now. And after that, go and find number 26. Done. Okay, so for number 26, we come to this word called diagram. I must say, you definitely have learned this in lower sec. But I also can say, you confirm have forgotten everything already. Unless you're that 1 or 2 very good student. Then very good lah. Otherwise, you try your best to recall everything. Technically speaking, I do not need to teach this part one. But I have a feeling if I don't teach, you score 0. Or you cannot remember any single thing. Okay, what's diagram? This is diagram. Okay, you see the picture, you know already. Okay, first of all, you know what's element? Element, this is the element definition. Cannot be broken down. It's the simplest. So let's look at the diagram that represent element. Okay, it means it's the simplest really lah. Like white color circle means white color circle. You cannot chop the white color circle and turn it into a black color circle, right? Cannot. It is the simplest. 1 white color circle. Okay. This is also an element. Yes. 2 white circle joined together is called an element. Confused? You know what's compound? Compound means what? This is not a compound, you know. Compound is 2 or more different. Yeah, spell different wrongly. D-I-F-F, right? Double F. 2 or more different elements, you know. 2 or more different elements chemically combined. First thing, I only have 1 element. How? Therefore, it's not a compound. Understand? There's only 1 white circle. Unless you go and find for me a black circle lah. Then you can tell me, the white circle represent carbon, the black color circle, but then don't know what element. I only have 1 white circle and it's the same white circle. So there's only 1 type of element. Understand? Like H2 hydrogen, H2, like 1 H here and 1 H here, you know? It's still an element, it's still hydrogen. So it's an element. But I call it diatomic, guys. I don't call it diatomic. You know what? You know why is it called diatomic? Next, I call it triatomic. I trust you know why it's called triatomic. Because there's 3 atoms. Okay, chemically combined. But only a single element. So it's still an element. Okay, it's not called a compound. Okay, now I have a different element. All represented by black circle, but it's still an element. It's not a compound because a compound need 2 different elements. So in this box, you only see 1 black circle. You only see 1 type of circle called black circle. You don't see any other circle or other type of circle. Okay, so you can call it a compound. Any question? So very simple lah. Okay, so it's called tri. Okay, and it's called molecules. Okay, this one is not a molecule. This is an atom. You know what's the difference between atom and molecule? Atom means atom lah. 1 only. 1 circle only. When you combine, you get diatomic molecule, triatomic molecule. So molecule means not atom. Atom means only one alone. After you merge already, it become molecule. Okay? So you merge 2 things, but they are the same thing. So it's element, molecule, element. Then you merge 3 things, but all these 3 circles are the same thing. Same circle, same type of color. So it's an element, but it's a tri-atomic molecule. Okay, let's move on. Compound. Yes, compound. Today we just learned compound the definition. I must have two or more different elements chemically combined. So, do I need to explain? You look at this picture. Do you see them join together? Yeah, you see them join together, right? So it's chemically combined. Or the white circle and the black circle join together, right? So they join means covalent bond, you know, the circle join. So it's chemically combined. And it's two different elements, one black, one white. So this represents a compound. Okay, in this compound, how to get this compound? I get 1A and 1B to combine. Okay, and I have 3 molecules. 1 molecule, 2 molecule, 3 molecule. Okay, any question? And in each molecule, there's 1A, 1B lah. Okay, or in each molecule, there's 1 white and 1 black. Now this is why compound. This is also a compound. Why? Because there are 2 different elements chemically combined. So I chemically combine what? I combine 1 white circle and 2 black circle. And I repeat 3 times. So I have 3 molecules. Each molecule got 1 white and 2 black. Understand? And together they form a compound. Because the definition of compound is 2 different elements chemically combined. So they are different, 1 white, 1 black. And it's true, they are chemically combined. Okay, next one, compound Z. Same lah. Now instead of 2 black, 1 white, I get 2 white, 1 black. Okay, they are all chemically combined because they join together. So it's a compound. W is also a compound because I have 3 different elements. I have what element? I have 1 white circle called element A, 1 black circle called element B, and 1 shaded circle. I don't know why my shaded circle go where. It's called element C. Okay, well, my notes cannot make it. Must change a bit lah. So it's a compound, 3 different elements chemically combined. And I have 3 molecules because 3 molecules every molecule got A, B, C. Okay, this one. Is it like an element or compound? The answer is quite easy, right? This one is a element. Why? Because definitely a compound. Compound must have 2 different elements. There's no different. There's no all same 1 white circle. Okay, this is a compound. This one I don't need to say you know lah. There is like so many different joined together, different color, different pattern, different elements chemically joined or chemically combined. Okay, do I need to write the reason? I need explain your answer. There is only 1 type of circle / element. Okay, compound there are 1, 2, 3 different. The word is different 3 different types of circle. Or in other words, 3 different types of elements chemically combined. And any question? This one like simple primary school, just check pattern only. Okay, next question, draw. You know draw. Draw for me. 2 molecules of compound J. 2 molecules means 2 sets. So in each molecule, I must have 2A. So what A? A is white circle Okay, let's draw. Join together, all join, chemically combined, chemically. 2 white circle and 1 shaded circle. Oh, okay. So I join Can. So this is J lor. So J consists of two white circle, one white and one what you call stripe circle chemically combined. And I want two molecules. So you can draw one more set. Okay. So each molecule there are two white and one shaded. Two A and one C. Okay. Let's see. Okay. Now I have a mixture. Wow, it's die. Well, what is a mixture? Two or more different substances. I don't use the word element, okay? Two or more different substances not chemically combined. So I have three possible mixture. Okay, mix element plus another element. Don't combine them, don't join them, but mix only. So I can mix different element. Okay, I can mix compound, but I don't join them. I can mix this compound, mix this another compound, different compounds inside, but I don't join the two compounds together. Or I mix element and compound. So I element inside, I shake with the compound, shake, but I don't join them. So it's a mixture. So let's look at the first example, mixture element. So I have two elements. See, I have this is called element A, and that's called element B. Element A is represented by white circle B. So I don't join them. They are not chemically combined. If you chemically combine them, one white and one black could join together, then this one will become compound. But you never join them. You see the picture? You got join them? You never join them. You never join them means it's not a compound. If it's not a compound, then you got so many things inside, you mix them together, it's a mixture. Or you mix A and B together lah, but you don't join A and B. Okay, next one. It's the same pattern. So this is A, and that is B. A and B is separated. The white and the black circle don't join together. You see? The white and the white together is still white lah. So the white and the black are two different elements. Yeah, there are two different elements, but not chemically combined. They are not chemical. So if they never chemically combine means it's not a compound. So it's basically I have two different things. I just mix them together only lah. It's a mixture of elements. Okay. Element A and element B. Is there a compound? No, there's no compound. So it just mix two elements together. So now in this question, I want you to draw a mixture of elements with two atoms of A. So A is white color, blank color. So just draw two lah. Atom. Molecule for B. And it's diatomic. Okay, so B is black circle. So diatomic. And don't go and join other thing. It's the same thing. The element. If you join other different one, then become compound. So it's the same thing. You join together, mine is still the same thing. Still element. And I need three sets. Okay, so let me go three sets. One set, two set, three set. They are all diatomic. Got two atoms joined together means two same atoms joined together. So it's still element. So diatomic element. Okay, then now try atomic. What I see? C is the shaded one. So you're going to shade lor. Okay. It's very difficult. Not very difficult, right? Can do. Okay, let's move on, shall we? Okay. Now I mix compound. Just now I mix element. Now I mix compound. So where spot the compound? This is a compound. You see? Got one black, one white. Different one joined together. So this is compound. This is compound X. Yeah. Let's look for another different compound. Because I must mixture of two compounds. Two different compounds. So I spot. Okay. So I got compound X that have one black, one white. Compound Y have one, how many? One black and two white. So they are not the same compound. They are different compound already. Like CO and CO2, they are different. CO is carbon monoxide, CO2 is carbon dioxide. CO is poisonous, CO2 is not poisonous. CO you breathe already, you will die. CO2 you breathe already, you won't die. So it's not the same thing, okay? Okay, so different compounds. Yeah. So different compound. So I have compound X black and white, compound Y black and white also, but two white chemically combined to one white, one black. So I have two different compound mixed together. So it's a mixture of compound. Next one, I mix element and compound. Where's the element? This is the element. Very obvious. It's alone, one single, simplest form. Okay, so this element. And where's the compound? This one is a compound. Oh, it's a compound. So I have element and compound mixed together. So it's a mixture element and compound. The element never go and join everything together. So it's on its own, just element floating around. Okay? So it's a mixture. Okay, now this one is ultimate. If you know how to draw this, I'll be very, very happy. Okay. After you draw with this, then we can actually done with the video already. I think the time is about 1 hour 10 minutes already. By the time you draw finish, maybe 1 hour 20 minutes already. So that's a 1.5 hour lesson. Okay, draw in the box. I want a mixture. So there are many things inside. 3 molecules of A. Element. I underline many times, element. So element means what? Means only got one type of circle only. A is what? Like that. Element A is empty circle lah. Oh. And I want diatomic. So make sure maybe join together one. So I need 3 of them. 1, 2, 3. Okay, so you're gonna draw one. Draw another one here. Draw another one here. Okay, diatomic. A. I want element A. Can don't confuse, okay? Okay, next one. I underline many times. Element. So only one type of circle. And what circle I want? B. B is a shaded. Okay. And I want atom. It's not diatomic, just one single atom. And I need 2 of them. So I'm going to draw 2 atoms for me. 1, 2. B is the shaded one. So far, okay. Drawing you, Spencer. Okay, next. Triatomic. Okay, underline many times. Underline is still element. Don't go and try funny thing. So element C is element means only got one design. And I want triatomic. Then you go and draw triatomic, 3 things together. And I only need 1 of it only. So very good. So I need only 1. So I just draw 1, 2. Triatomic, but only need 1 of it only. One molecule inside got 3 atoms. All same. Okay, can I erase? Okay, next one. A compound. Because I underline. I use red color. Compound. You know what's compound? Compound means got different circle joined together. So let me see what is X. Let's read. X. I need to join A and I need to join B. I need to join A and B. Okay. And how many? I pick only one A and one B and join together. So simple. One A and one B. So it's X. Correct or not? I mean, you read here lah. Compound X is made of one A and one B chemically combined. That's the definition of compound. So I combine them. And I need 2 sets, man. So yeah. 2 sets. So you go and draw. 2 sets. 1, 2. The last one, do you know how to do? Also a compound. And it's W. So W got what? W got A. I need only 1. Okay. B. I also need only 1. And C. I also need only 1. So like that. I'm going to draw inside. So it will be like that. like that, like that. Yeah, this is the answer. If you know the whole thing of this drawing, means you're very good lah. You know what's element. You know what's diatomic element, triatomic. Okay, so element is very good already. Compound, you know what is compound. Okay, also very good already. Then everything together become mixture. Also, this is a mixture. So many things mixed inside. The mixture. This is a mixture. Any question? Okay, if no question, okay lah. I don't know whether the bell ring already or not. If the bell ring already, then very good. You can stop the video. If not, can we just look at the MCQ? Okay, which diagram represents a mixture of noble gases? Okay, maybe you haven't learned what's noble gases. Never mind, I'll tell you. Answer is D. Noble gases is group 18. And group 18, they are monoatomic. That means they are not diatomic lah. Diatomic. This is diatomic. Oh, this is diatomic. Okay. Triatomic, I think you know what it means. So monoatomic means only one. And it's a mixture. So I must have one here, or one, but different. It's a mixture. One, the white and the black. So mixture. Oh, okay. Can. Okay, let's go to the last question. Yes, last question. I've been talking for 1 hour already. Oh, sorry, more than 1 hour. In the diagram show, which diagram represents a compound? What's the definition of compound? Two different elements. Okay, so let's look at this. This is wrong. There's only one single element only. This one also wrong. Also only one single element. This one, maybe got chance, got two different elements. One, don't know what lah, maybe represent oxygen. Then this one represent oxygen. Or this one represent H2O. So the H2O. So maybe the small one is hydrogen, H. Then the big one represent oxygen. So yeah, two different elements lah. So C got chance, What about B? B no chance lah. B got two different elements. Correct. But remember the definition? Two different elements chemically combined. Yes, it must be chemically combined lah. You know what's chemically combined? Means must combine, must join. The two elements must join. The two different elements must join. You know got join. This one is like all separated, cut into pieces. So B is wrong. So the answer is C. But yeah, answer is C. Correct. This one. Okay. Any question? If no question, finally, I can stop share. Okay, let me stop share. Okay. This will be the end of the video. I'll stop recording now. If you need to go through it again, just watch the video one more time. Okay. If not, thank you very much. That's the end of the lesson.